Hi, my name is Bahadur Ahmedov. Welcome to the course of Probability and Statistics. In this lecture, we're going to discuss how to construct the confidence intervals for population means using so-called T-tables. So last time we already discussed this topic. So we say that, hey, if you take a samples with the size more than 30, then we can calculate the mean. And the distribution of those means of the samples have the normal distribution, and this helps us to calculate the interval. So we basically, knowing the confidence level, we can calculate the critical points and use these critical points in order to construct the intervals. And the question is actually, what if the sample size is less than 30? It appears in this case, we need to use so-called T-distribution. So technically, so algorithmically, nothing is changing. Technically, so the only thing which is changing here in this formula where we are going to construct the error margin and use this to construct the interval, this Z critical point is going to be simply T critical point, and we're going to just find this differently. So algorithmically, nothing changes. Technically, something is changing. So we are going to discuss today how to find this T. And before we do this, I would like to give you, I would like to do a little bit discussion about this error margin and what is this. So if you remember, in order to construct the interval, what we need to do is we need to take a sample, calculate the mean, and then calculate the error margin and construct the interval. For example, if the mean of the sample is equal to the T and error margin is equal to the 0.1, then our interval is going to be between 1.9 and 2.1. So we basically say, hey, so I'm confident C percentage that the mean is going to be in this interval. Or sometimes we write this in this way, right? So I'm pretty sure that you've seen this kind of notation in a package of sugar or the potatoes or the chocolates, where it is written like average netto is equal to the 1,000 grams plus minus 5% probably, right? So this is exactly the construction, the confidence intervals. And I would like to give you, so now what I would like to do is I would like to increase this error margin. So if I increase the error margin, therefore the same mean, then my interval actually is becoming larger, right, than before. So previously, if the error margin is smaller, then the interval is between 1.9 and 2.1. Now, if the error margin is 0.5, then the interval is bigger, right? So actually, so since I'm estimating the population parameter, I would be interested to have the smaller interval, right? So I would be more sure about my interval, the smaller interval. So when the interval is large, so it's not really, doesn't make really sense, right? So if I just ask, hey, what is the height of the students in our group? And if you say me, hey, this is like 1.5 meters plus minus 1 meter, right? It doesn't really help, right? So I would be interested to have the smaller interval. And the question is it possible to control the size of the interval? And it appears yes, we can try to control this. And one of the ways to control this is to control the error margin. So if you remember, the formula for the error margin is looking like this. So it is the multiplication of the critical point times the sigma, the standard deviation of the population or the sample, divided to the square root of n. So here, the n is the sample size. And if I start to increase the sample size, if I take more and more items to my sample size, so this formula tells me that your error margin is going to be smaller. And this is logical, right? So if I would like to have more better estimate of the population parameter, then I need to take more greater and bigger sample, right? So if I increase the n, the E is going to be decreased. And another thing which I can control is as well the critical points or confidence level. So this critical points depend on the confidence level. If I would like to be more confident about my interval, then the critical points are bigger. It means that the error margin is going to be bigger. So if I make this T, the critical point, smaller, then the error margin is going to be also smaller. So what does it mean? It means that if I would like to be less confident about my interval, then of course I can make it smaller, right? So you need to always keep in balance, like what you can choose for the n, what you can choose for the confidence level, and so on. So now let's discuss what does it mean, this T distribution. So in order to discuss this T distribution, we need to first of all introduce so-called the degrees of freedom. So for the T distribution, the degrees of freedom is calculated very easy. So you take a sample, for example, with 35 items, then you calculate the degrees of freedom by just taking the size 35 and subtracting the 1 from this. Or the sample size might be 5, just 5 items in your sample, and the degrees of freedom in that sample is going to be 4. So n minus 1. So it appears the t distribution is again the bell-shaped curve, but now for every degrees of freedom, we are going to have different shape of the curve. For example, if the degrees of freedom is equal to 25, then the t distribution curve is going to be very similar to the normal distribution, right? And if I would like to find out the critical points, what I have to do is I need to define the confidence interval, confidence level. For example, for the 90% of confidence interval, this area in the middle is going to be 0.9. Then I can find these 2 critical points, right? So what if I decrease the degrees of freedom? What if my sample contains less items? In this case, the curve of the t distribution is going to be different, slightly different. For example, for the degrees of freedom to be equal to 8, the curve is going to be like this. And obviously now, this area is not C anymore, right? So this is going to be smaller than the C because the curve now is more flat than before. It means that this area in the middle became smaller. So in order to make it again C, what I have to do is I need to make it bigger, right? So we need to just make the critical points bigger, okay? So if the degrees of freedom is even smaller than, for example, if the degrees of freedom is equal to the 3, so now our curve is becoming even more flat than before. It means that the area in the middle is even less than the before, right? So in order to make it again the C, what we have to do is we need to again increase the interval, take the bigger critical points, okay? So there is a table which allows us to find those critical points, but at this stage, it is more or less logical, right? So if you take less items into your sample, then the critical points, the critical points are going to be higher. It means that your error margin is going to be higher. It means that your interval is going to be bigger. So now let's discuss how to calculate these critical points technically. So it appears in order to do this, we need to again use the simple table. So in every statistics books, you will be given a table which is going to tell you what is the critical point for the t distribution, depending on the degrees, of freedom. So I'm going to show you this table one more time. So here in this table, you can see the first row means the degrees of freedom, and so the first column. The first row means here the confidence level. So if I would like to, if I would like to know what is the critical point where the degrees of freedom is equal to the 4 and the confidence level is equal to the 0.9, then I need to choose this number. For example, if the confidence level is 95% and the sample size is 5, find the critical point. So in this case, we need to find, first of all, degrees of freedom, which is going to be 5 minus 1, right, 4. Then we need to find the confidence level from the first row. It's going to be 0.95, right? Then this number, 2.776, is going to be our critical point, which we're going to use, plug in to the formula of the error margin. So we can find the critical point, for example, when the sample size is 12. For example, if the confidence level is 95% and if the sample size is 12, then again, I need to go to the 11 here because the degrees of freedom is n minus 1. And then I need to find the confidence level from here. It's going to be 95%. Then I need to find this number. It's going to be our critical point again. So now let's solve the problem and see how to use all of these things, which we have learned in a technical way. So let's say I've got the sample of 12 items. What I have to do is I need to construct the confidence interval for the population mean. So I would like to know, hey, what is the average of the population? In order to do this, I took a sample of only 12 items. Now I would like to estimate, just knowing the sample, the population mean. So the first step, what we have to do is we need to find a mean. So if you remember, in order to find a mean, we need to sum all the items and divide this to the number of the items. So in this case, it's going to be 84 plus 14 plus 583 plus 50 plus 0, and so on. And the sum of all of these items is going to be 1,275 over 12. So this is the mean of the sample, and we're going to denote this as the x bar. So our next step is to find the standard deviation of the sample, right? So since we are not given the standard deviation of the whole population, we need to find this. And if you remember, we need to use this formula in order to find it. So we are going to find the standard deviation in the square, which is called the variance of the sample, right? So in order to do this, what we have to do is once we found a mean, we need to subtract the mean from every item in our sample and take its square. For example, 84 minus 106.25, or 14 minus 196.25, or 106. I think it should be 106. There is a typo here. 106.25 in the square, and so on. We have to do this for all of these items. We take every item from our sample, we subtract the mean, and take the square. And at the end, we need to sum all of this differences in the squares and divide them to the n minus 1. In this case, it's going to be 12 minus 1. So this is going to give us the standard deviation or the variance. Basically, it means that we are finding the average distance between all the points from the mean, right? So the point minus the mean in the square is going to give you the distance between the point and the mean. When we find all the distances here and sum them and divide them to the number of the distances, actually, it's going to be equal to the average distance between all the points and the mean. So if we do the calculations, we are going to get here the number 297,000 over 11. It's going to be 27,005. So this is the variance. So in order to find the standard deviation, we need to take the square root of this, and the standard deviation for the sample is going to be 164. Please note that whenever we find the standard deviation of the sample, we have to divide this to the n minus 1, not to the n. So now, what we know is we know the mean, we know the standard deviation, and also we know the critical point, right? So before we start talking about this problem, we discuss, hey, if the confidence level is 95%, and if the sample size is 12, then what is the critical point? So the critical point was 2.776 or something this roughly, or 2.201. So now we need to calculate the error margin. So in order to calculate this error margin, we just need to use this formula, right? So we just substitute all the values for the critical point of the t, for the standard deviation, and put the square root of 12, and this is going to be 104. So once we get this error margin, in order to construct the interval for the population mean, what we have to do is we need to add this to the population mean and subtract this from the, add this to the samples mean and subtract this from the samples mean, right? So if I subtract, I will get 1.84. If I add, I will get 210.66. So that is why our confidence interval is going to be between 1.84 and 210. So this is how we need to construct the confidence interval using the t table. And here is an algorithm and the guides how to do this one by one. First step is to find the sample size, find the sample mean by just adding all the numbers and dividing them to the n, specify the standard deviation of the population. So if you notice, then if the sigma is unknown, then we need to specify the population. So basically, if the population is normal, then we can use the t-distribution, and we can use the sample standard deviation as the standard deviation of the population. If not, then there is a different question. So find the degrees of freedom. In this case, it's going to be n minus 1. Find the critical points t that corresponds to the given level of confidence and also degrees of freedom. Then find the error margin just using this formula, where here it should be t critical point, and at the end we need to construct the confidence interval by just subtracting this e from the mean, samples mean, and adding this to the samples mean. So well, this is almost it, but there was a main question still is here. So I've got this question because in the previous lecture we've used the z distribution, and this lecture we use actually the t distribution, and I'm a bit confused in which case we need to use the z distribution and in which case we need to use the t distribution. So we are going to discuss, I would like to see the more clear and great picture of what I have to do, like a simple guide, step-by-step guides. So in our next lecture, we're going to discuss like a step-by-step guides, when to use the Z distribution and when to use the T distribution.